Hey everyone, thank you so much for checking out the Weaviate podcast. We have a super exciting episode. Etienne Dilocker is back on the Weaviate podcast, and we're going to be announcing what's new about Weaviate version 1.14 in this podcast format. So hopefully this kind of style of having this conversation around the new changes is a nice companion to, announces of new software and things like that. And I'm really excited about kind of rolling out Weaviate version 1.14 in this kind of style. So Etienne, if you had, say, one sentence to explain what's new about Weaviate, what would it be?
Yeah, hey Connor, thanks for having me. I would say this is the most boring release that we've had so far, and I'm super excited about it. So what I mean is it's all about reliability, about running Weaviate in production. So all that feedback, we've recently passed 1 million downloads, and all that feedback that we got from our users running it either in their evaluation setup or in production, they discovered a lot of issues, and we fixed them all. And basically, this is all in this release. So I'm super excited about it.
So we have the bullet points of the different topics that are going to be covered in the chapters of the podcast as well for people listening. If you want to jump ahead to the different parts of the release that you're the most interested in, but Etienne, could we start with what's new about monitoring and observability? What
Yeah.
does that entail?
Yeah. So observability, I think in any new software project, it's like always one of these things where like you need to design software in a way that it's observable because, well, if it's not observable, you don't know what's going on, and then it makes it super hard to run it like in a production setup where, you can't monitor it as closely. And with Weaviate, I think for the longest time we've kind of said, yeah, it's coming, and it's finally here. So with this release, we're adding a Prometheus compatible monitoring. So Prometheus is a sort of a very standard, I would say, industry standard for monitoring tools. Essentially, it's just a format. It's just a format of how the metrics are presented, but it comes with that whole Prometheus ecosystem. So you can basically just plug in standard software like your standard Prometheus, a time series database, standard Grafana for visualizing those metrics, and all of a sudden you have like insights into Weaviate that you could never have before. So you can get all these dashboards and really for everything. So it's, I think over the past couple of weeks we had like a rough plan of what metrics we would need, but we kept on adding more and more metrics because it's just so easy to add new metrics now. So a very typical example case would be importing into Weaviate. So let's say you're importing a relatively large, say, I don't know, 100 million plus, and all of a sudden it starts getting slow. So that was definitely one of the, and also when we talk about the reliability fixes later on, that was one of the topics that could appear in the past. So a community user would maybe say it's suddenly slow. And then we would go, oh, well, that's not supposed to be like that. But it's kind of hard to tell what's going on because, well, not only is it not us running that instance, like Weaviate is self-hostable, so users can run it themselves, but also how would they know, basically? And with the monitoring setup, this is now super easy because every request that comes in, so for example, a batch import that is split into its individual components, so it's being imported in the vector index, in the object storage, maybe in the inverted index if you're building that up as well, and then all of these components are split up further. But that gives us a super easy insight to just say, oh, look, we can see that the vector index is fast, but the object index is maybe slowing down. So ever since you crossed, I don't know, 100 million objects, because you can, of course, also overlay that. So you could say, like, okay, at that point, you had 50 million objects imported, and all of a sudden there was a jump maybe in the time to import one additional object. And that gives us and our users and everyone operating Weaviate a lot of confidence and a lot of insight into just figuring out what the issue is and fixing it. So I could easily say like, oh, it looks like you have an issue with your disk maybe, or something else in the setup. Like, yeah, before it was a lot of guesswork, and now it's I guess debugging is still detective work, but now the detective has like tools and has hints to basically figure out what's going on.
Yes, I'd really love to dive more into the incremental buildup of the HNSW graph and get back into the technical details of that topic. But just one more time. So Prometheus, it's like a visual dashboard, kind of like a graph where you say you have this much RAM has been used, this many vectors are. What does the visual of it look like?
Yeah. So basically, Weaviate itself just comes with those metrics, and we can, like, everything that's going on, we can basically measure. And Prometheus is kind of the format. But Prometheus is very typically used in combination with Grafana, which is this dashboard provider where so users can define their own dashboards. They can say like, okay, I want to combine this metric, or maybe see like how a metric changed over time, and these kind of things. And of course, we also have we have a couple of sample dashboards. So if you want, you can have like this one-click setup where you say, hey, so we have in our Weaviate examples repository, we have the setup, you just spin it up and it has everything pre-configured, and just you start using Weaviate normally, but now you can open up that Grafana dashboard and you can just see what's going on. So yeah, it's a very, very visual way. You can of course also use those metrics programmatically if you want, but like with Grafana, it's super easy to just visualize it for the users, for the people having to operate it, for everyone that's involved in sort of making their case with Weaviate a success case.
Yeah, it sounds super exciting, especially for very big scale. I imagine that it's very useful to have. So does this relate to, say, the horizontal scalability idea we talked about earlier, where you're using more than one machine with Weaviate, and does this help you kind of monitor that as well? Do those kind of play together a little bit?
Yeah, exactly. So Prometheus is really, I would say, sort of a cloud native tool. So it does stuff like orchestrating across nodes, does that very well. So you can aggregate. Basically, you have two ways. Like you could say, is there something going wrong on maybe one specific node? And then Prometheus just adds a label to it for each node has a name or has a host name or these kind of things. So it gives you a label to narrow it down. Or you could just say, well, I want to treat this Weaviate setup that's composed of multiple nodes as one unit, basically for my use case, and just tell it to aggregate those metrics as one, and then you can do it as well. So that's basically this granularity would be you start with the setup like you could, let's say you would have a multi-tenant setup of like multiple Weaviate instances, and that would be like the highest one, where you would say maybe as a Weaviate user, you yourself have like different users, and then each user has like its own Weaviate instance, for example. Then that would be the first level of granularity. Then per user, you would have this one Weaviate setup. The Weaviate setup itself might have multiple nodes. On each node, you would have maybe multiple Weaviate classes. They could be comprised of individual shards. So basically, you can go down as deep as you want until you have like individual objects, or even deeper on disk, or you could go like very high. So this gives you sort of the ability, and Prometheus does that very well to just aggregate those individual labels across whatever you want, including distributed nodes in a cluster setup.
Yeah, super exciting stuff. And I definitely want to talk also about multiple classes. And to quickly kind of background this for listeners, we have this kind of semantic relation data schema design where you could say have one class would be, say, tweets, and then you could say like has article link, and then maybe you want to store like an article as another class, like has another image. So it's a way to do multimodal data. It's a way to say decompose your data. If you have a scientific paper and you say want to have has introduction, has related works, has methodology, you can break it up into multiple classes, and then you could have HNS-W structures for each of the classes, if I'm understanding that correctly. But so could we kind of come back into the incremental buildup of HNS-W? And I think that it ties into the monitoring as well, just to maybe get a little more into what's happening. So with HNS-W, my current understanding of it, again, is we have this proximity graph. And so maybe you could take me through how you compute the proximity graph, and then how you incrementally build up the neighborhood graph to facilitate nearest neighbor search at massive scale.
Yeah. I'm gonna try to keep this as short as possible so we don't explode the entire podcast about it, because I love talking about this. But no, in general, the idea of the proximity graph is that a nearest neighbor in the graph basically is a nearest neighbor in the terms of nearest neighbor search. So the distance, and that may also be a good segue to one of the other topics when we talk about distances later on. The distance between two neighbors in the graph is lower than the distance between a neighbor where you'd need two hops through the graph. And that is the same like if you import two objects, or maybe three objects or five objects, or if you go to hundreds of millions. Like there is a point where if you want to, you can shard this up into like multiple instances or into multiple indexes, basically. If you say, for example, with this very large machine, I can hold 500 million on a single machine, but the machine is simply not big enough to hold more than 500 million, but I need 3 billion, for example. Then you could say, okay, I'm going to split this up into 6 machines that each hold 500 million. And then each of those machines would have their own HNSW graph. But from a user's perspective, you wouldn't really notice because the results, basically, if you do a search, it would search all 6 graphs in parallel. And then because we all have this distance metric, it's basically, in a sense, it's re-ranking, I guess, kind of a fancy term. But yeah, it basically just means we take those results from those 6 graphs and basically aggregate them. Yeah, and with the monitoring, you can watch the graph grow, basically, so you can see live like how many objects are imported. And it also has a couple of, so the graph itself, basically it grows exponentially, so you need to reserve memory, and this kind of growing operation is a bit costly in the sense that while it's growing, nothing else can be going on. So it's like for the highly concurrent setup, you need synchronization. And I'm just throwing in buzzwords now. So basically you need to lock this graph. And this is something that yeah, you could see before, or that we couldn't see before because we didn't have the monitoring, that the way that we grew this graph, that wasn't necessarily optimal, because it cost too much time. And now with the monitoring, we could say like, okay, yeah, this our growth interval of the graph is too low in comparison to how far we've already made it. And this was to the point. So this is one of the reliability fixes that we have in this release, to the point where we did a load test ourselves, and I think beyond 50 million, it was very noticeable that it slowed down. Like there was no problem as in you couldn't import more than 50 million objects in Weaviate, but going from 0 to 50 million was super fast, and going from 50 million to 100 million was all of a sudden really slow. And the culprit was actually the way that we grew the HNSW index, which was super, super easy to visualize. Like in our monitoring, this is now just like, or it was like a graph that was just like steps, basically, how the index would grow. And then you could easily see that just sort of the amount of data that we imported compared to the growth cycles just didn't make sense. So all we had to do is like change this from a linear to an exponential growth setup. And now, yeah, the growth operations are relatively rare because I think it grows by like 25%. So if you already have 100 million objects imported, the next growth operation would go to 125. And then, yeah, you wouldn't have to grow it again for the next 25 million imports. And that was the entire reason for why imports slowed down. So it's something as significant as, well, Weaviate slows down after 50 million. Yeah, just a simple change in the growth. And this is something that in this case, we as the engineers could tell basically from the monitoring. But all kinds of these things, I think, like whenever you have a problem with Weaviate in the future, just look at the metrics and just see like what's going on. And typically, if you have a bit of a feeling for a bit of experience with Weaviate, it will be very easy to just pinpoint, okay, yeah, this is the reason.
Yeah, I love that, and I love the numbers behind it. When you start thinking like 50 million, 100 million, you start putting some numbers behind how many vectors can I load. And I think maybe coming back to our ANN benchmarks, I love how that puts some numbers to, you have a million vectors, you want to search through it. The vectors have this dimensionality. This is how long it takes. I think having these numbers out there really helps just understand what's happening. And so I think with the Wikipedia example, it's like 280 million paragraphs or something like that. Just kind of thinking about some things we can do, like putting all of Wikipedia into Weaviate. And
yeah, I think it's a bit smaller than that at the paragraph level. I think at the sentence level, it would probably be in the hundreds of millions. I think it's in the tens of millions, but I'm not entirely sure. But yeah, but just this kind of scale, like it really is big data in a sense. I mean, that's just, I'm really just throwing in buzzwords today. But I mean, like what is big data? But yeah, that is like millions, tens of millions, hundreds of millions, billions. And we're talking about like at the billion scale, we're talking about, okay, what are the kind of optimizations that we can make to sort of make that less resource intense in the future. But we're never talking about like, can I achieve it at all? Because yeah, it's there. You can do it right now.
Yeah, amazing. So it's the idea of like, say, putting all of archive into Weaviate, and I love the big data and kind of what that unlocks. And yeah, I'm sure there's a lot of, so I think kind of going from this topic now, I think that was a good coverage of monitoring observability, understanding, and maybe quickly to clarify it. So the HNSW graph you build up, as you scale up horizontally, you'll split the proximity graph and you'll have separate proximity graphs for each node. And so kind of coming back into the approximate nearest neighbor search is kind of like that stochastic algorithm where you have that kind of approximation. So is that a correct understanding quickly before moving on?
Yeah, absolutely. And it's really the important thing here is you can configure it in whatever way you want it. There is a disadvantage of splitting it out, mainly because you're spending basically your resources twice if you have to traverse two graphs in parallel. Um, so that there is probably a point where it doesn't make sense and you don't have to do it, but it's full control to the user. So it's really you can sort of build up in the same sense that HNSW itself also has hyperparameters where you could, and I think our benchmarks page really visualizes that nicely, where you could use different build parameters to sort of get a different performance metrics out of the graph. And I think sharding it into smaller segments is just one more of those sort of build parameters in a sense.
Is this approximation, is this captured in the ANN benchmarks? Does the ANN benchmarks have the scale where you do this kind of thing?
It's currently all a single shard in there, so
Single
that's
shot.
not captured yet. But that's a good point. Like we could add a sort of a very large scale benchmark, and that's definitely something that we have on our roadmap anyway. And we could sort of capture that as well. Like how does it change if you build it on, let's say, a single very large machine as opposed to like 3 or 4 large machines or something like that. So yeah, good idea.
Yeah, really exciting. And maybe just one more thing on the ANN benchmarks. Maybe just like a little bit of. I'm a little curious how you have the benchmarking script and the server script, and then the HDF5 files where you have the ground truth and how people can contribute their own data sets to ANN benchmarks. Can you take me through the setup of that? Like if I have my Wikipedia vectors, right, and I want to add it to ANN benchmarks with Weaviate, how do I do that?
Yeah, yeah. The format that you mentioned, HDF5, and this is, I think HDF5 in itself is basically just like a container format where you can like put data very similar to like a folder structure on disk, just like in a single file. And the reason we chose this is because of ANN benchmarks on the great work that Eric Benhardsen has been doing there already. And just all the data sets that are present there are in this format. So this is basically the reason why we chose that format. So all you would have to do to run or to contribute your own benchmark is put that data set in that same format. And then for the contents, basically, you need to have the vectors, obviously. So all the vectors you want imported. And what's great about those existing data sets is that they have, so they're similar as you would have like a train and test split when training a model. They also have like this sort of predefined queries, just to make sure that everyone that's running that independently is really asking or is really comparing the same thing. So it will always be the exact same queries. And I think it's typically in those data sets is something like 10,000 queries as part of the set. So let's say the set has like 10 million or 1 million or 10 million or something like that objects. And then you query the same 10,000 vectors. And because it's the same vectors that you query all the time, that also means that you expect the same results. And this is what the ground truth is. So the ground truth is basically just using a non-approximate nearest neighbor. Well, not algorithm. It's not really an algorithm anymore, but basically just brute force search across the data set, which is slow, but it's basically only done once for each query. And then for each query, we know the exact nearest neighbors, which are the ground truths. And then all we have to do is basically compare this. And this is what the benchmark script then does. So we have a very simple script that basically it spins up Weaviate with specific configuration. You can tune that. It's very simple, actually. I think the only sort of non-standard configuration in there is we've slightly tweaked the garbage collector to be a bit more aggressive in reserving memory, because we've sized the machine relatively largely, so we don't get interrupted by garbage collection cycles. But that's an optimization that everyone can do, so there's no sort of secret magic. But that, I think, is the only thing. And then the benchmark script basically just takes that HDF5 files, extracts the individual vectors, and just imports them. And after importing, it queries them. And for querying, it uses the query vectors and compares the results that Weaviate will give you to those ground truths. And then basically the overlap is the recall. So if out of those 100 results, only 98 are part of the ground truth list, that basically means you're missing 2. So you would have 98% recall.
Yeah, I think this is also exciting. What's the recall looking like? How fast is it? How many vectors can I load into Weaviate? Having this monitoring observability, seeing it get uploaded, so you're not just like looking at it loading and you see. yeah, all of this is really bringing it together and putting some numbers behind it was so exciting. So in our podcast of our release, we're now going to kind of pivot into a different topic now. So let's talk about vector distance functions, cosine distance, L2 distance, dot product. What's new with that?
Yeah. So if you've seen the benchmarks, there's actually I think some data sets are angular distance, which is cosine distance, and then one is using L2 or Euclidean distance, and that is something that's actually new. So this was kind of a silent release before. The version that was released with the benchmarks already supported that, but it wasn't officially supported yet. So we would not find anything in our documentation about it. And the reason for this was we had to sort of we had to figure out how to do this in the APIs correctly, because in the past there was like one sort of single number that always controlled all the distances, and that's the certainty. So whenever you get a result back, you could display the certainty, and the certainty was always guaranteed to be a number between 0 and 1. 0 would essentially mean like there's absolutely no match. So it's like in an angular space, you could say it's the opposite vector. So if one vector points in one direction, that would be the vector pointing in the exact opposite direction. In not all spaces, basically. Or yeah, that is a good point of sort of why we need something else. So basically, you have this bounded score between 0 and 1, which works perfectly for cosine distance, because cosine distance, yeah, it's an angular distance, and an angle can only have like 360 degrees, basically. So it's a limited range in a sense. But now if we're looking at a Euclidean distance, for example, if 2 points can be infinitely far away from one another. So this distance, basically, there's clearly a minimal distance that they can have, which is 0 if they're identical. But there's no maximum distance, because you could always basically have coordinates that are higher than other coordinates, so the distance would increase. So what we're noticing is that general idea of saying you have a distance score between 0 and 1, that kind of breaks with other distances. And Euclidean distance is just one example. You could also have a dot product, for example, where it's then the opposite way. Like dot product, basically the closer they are, the higher the dot product. Well, it's also not entirely correct, but a bit of an oversimplification. But here, basically, you have a higher number if they're more similar. So generally, what we're noticing is this idea of just putting it in a number between 0 and 1. That's nice. That's easy to understand, but it's not very flexible with different distance metrics. So what we're doing right now in the 1.14 release is we're introducing an actual field that's called distance, and what you get back in that field is just the raw distance. So if you're using a different distance metric, and this is the new feature, that you can use different distance metrics. If you're using cosine, nothing changes. Everything is the same. You can still use certainty. But if you use a distance metric that simply isn't bounded in that a small range, then you can just use the raw score, and you can interpret it in whatever way you want. If you could, for example, come up in your application with a way to normalize that into a specific range, that's all fine. But basically, we as Weaviate don't want to say like, yeah, we're doing some elaborate calculation here, where then users ask like, okay, I'm using dot product. Why is this number like? Why doesn't that match the raw dot product that I could calculate outside of Weaviate? So general idea is just less magic. Just sort of pass the actual values through, and users can interpret it in any way possible. And that was the major reason of why we didn't release the distances previously yet, because we need to figure out how to do this properly in the APIs for like a proper user experience for custom distance metrics. That's the first part of it. Then there's something else that I personally, and this is the engineer in me speaking, and that I find super interesting about distances, is the most CPU time that we spend in Weaviate is typically on calculating distances. So even with these ANN indexes such as HNSW, it's basically just a smart way to compute fewer distances. But in the end, how many distances you can compute and how efficiently you can compute those distances really determines the performance and throughput of the whole vector search engine. And there we have sort of specific, and this is something that we're also releasing now with the new documentation for 1.14. there's a clear overview of what kind of optimizations are in place for Weaviate. So to very quickly dive into how this works from a coding perspective, Weaviate is written in Golang, and that is unfortunately a bit limited with these like really low-level optimization. So in C++, for example, you get this vector intrinsics API that you can use to do like parallel computations on a single CPU cycle. Golang doesn't have that. So we had to be a bit creative and had to write that in assembly, which always, this is the moment like where the audience typically goes, whoa. So we had to do this in assembly, which I think it's cool that we have it. But at the same time, these kind of assembly optimizations that you do, you always do them for like one case. So you would say that this is, for example, for dot product on AMD 64 CPU architecture for let's say, I don't know, CPUs that support the AVX2 instruction set, which is typically Intel CPUs, for example. So long story short, we have that like completely transparent now in the documentation. And my hope is that maybe someone out there in the community who really likes dealing with this like really low level stuff is like, hey, look at that combination. Like, for example, there's missing an optimization for making this up, ARM64. I know how to use that instruction set. I'm going to contribute something. So that would be my dream to get a couple of open source contributors to really help us figure out like what what distance metrics can still, or not distance metrics, but distance computation functions, where they can still be improved, and make it an even faster experience for everyone out there.
Yeah, wow, that part of the ARM instruction, that's so over my head. I'm glad to be on your team where I don't have someone who knows that kind of thing, because I don't think I would ever figure that out. But that is so interesting how you can go low level to optimize the distance calculations and speed these kinds of things up. I find that whole thing to be so fascinating. And maybe we could return a little bit to the first part about the user experience. And kind of usually when I think of user interfaces, I think of these visuals and CSS and that kind of thing. But these little design decisions like certainty or distance and kind of what that relays to you. Like I like using when you have the near text search, you get the certainty under the underscore additional certainty that shows you the distance. And it's really useful for, say, earlier we mentioned re-ranking, if you want to see the distances from your query of the documents and maybe have some extra processing based on that. And having that distance, just kind of how it helps people understand it. Because maybe I was curious about the original design of certainty, because do you think about vector distances in that kind of probabilistic sense, like where you have this kind of certainty of saying I'm this certain that this vector is similar to this vector, kind of in the same way? Because I think when you have like the question answering example, the certainty is very like clear. You have a good sense of what that means. But with vector distance, how do you think about that kind of like use of certainty or distance, just the little naming and what that tells people about what it's doing?
Yeah, and I think that was exactly the original idea of not going with a raw distance, because way back, sort of before Weaviate version 1.0, before everything was modular and before the whole sentence transformers were a thing, what you would typically or what you would do with Weaviate then was you would only use it with the contextionary. So basically, we were in control of that whole sort of model space. And there was just one thing, and then our general idea was like, okay, like if all of this is abstracted away, the user does not need a distance. They just need something to indicate them, like, okay, the model is somewhat certain that these things are close matches, whereas in other cases the model isn't as certain. Obviously, we've come a very long way since then. You can still use the contextionary as a sort of simple simple model with Weaviate, but also there's this whole research out there, new models sort of popping up every day, and you can use any one of them. And that makes it a bit more difficult to claim that something is more or less certain than something else, because every model will do that differently. So sometimes you have models where like everything is in the 0.99 to 1 certainty range. And then you have another model where like a perfect, almost identical result has like a certainty of 70%. So that kind of highlights that as we've opened up Weaviate and we're making it more flexible, and we're enabling all those cool data science teams that have their own models. It's very hard to make this one claim of like, this is how certain something is. But of course, you can still use certainty in the future on anything that uses cosine distance. But yeah, you'll also just get the raw distance to sort of have an opinionated way of basically just having an objective number, and you can still sort of put something on top of it of saying like, yeah, distance larger than x means certainty y.
Yeah, super cool. And yeah, the I love the GraphQL interface for how you access these things too. Just kind of maybe come back into the whole designer thing. But so back to our release podcast and pivoting topics. So this now the next chapter is about reliability and bug fixes, and I'm so interested to hear also about how the community plays into this. I'm so impressed by your ability, Mars and Stefan, and everyone's ability to answer these questions that come up on Slack. I see these questions come up in the Slack chat, and I'm like, well, that would be like a day for me to try to figure out. But it seems like you all can just answer the question quickly, and so I'm really curious to hear how that whole ecosystem plays with developing these things.
Yeah, it's I think it's first of all, thank you very much. This is super great to hear, because I also think like our community is our strongest asset in that sense. Because yeah, we've now crossed 1 million downloads, which is a lot of users, and we've sort of, I think Weaviate 1.0 has been out for like 1.5 years. So there's just a lot of usage out there, and that gives users the guarantee that what they're using is something that's battle tested. And at the same time, every single user using Weaviate is essentially a QA engineer for us, because their stress testing is, and like no one is as creative as our community in trying to find ways to break Weaviate, and that is awesome. That is exactly what we want and what we need. So that's also how sort of how we can be so enthusiastic about bug reports. Because like, think if someone's asked me at some point like, oh, aren't you like 3 new bug reports this week, aren't you sad or something, or aren't you unhappy? And I was like, no, this is awesome. Like the bug was already there, now it's visible. And if a brand new piece of software that is sort of doing something so revolutionary, if that's not getting bug reports, then I'm convinced it's just not getting enough usage. Because like, I don't think Weaviate is any better or worse than our competitors with regard to preventing or not having bugs. But if it's being used, then bugs are being discovered, and then they can be fixed. And yeah, huge shout out to our team that's doing like spending so much time reproducing that together with our community users, and really identifying all these sort of from smaller issues to larger issues. So for me, the worst, I think there was a period in Weaviate's history that luckily that's gone now, but there was a period where you could get Weaviate to crash in a specific way that it wouldn't be able to recover. And that is, for me, that's the worst. Because what do you do? Like, yeah, that's the one thing that you don't want to happen in your database, is that it just stops being usable. And you basically have to throw your data away and start from scratch. That's fine if you're evaluating it, but that's not fine if you're running in production. And that has been fixed for a couple of versions. So I'm not aware of any more reports of people getting into these kind of situation, which is super, super important. But there was one sort of that I would still consider a very critical bug that we've now fixed with the 1.14 version. This bug, so Martin's always joked that this bug, like, it has many names, because it was a very simple bug, but it resulted in, yeah, you could say like in what was perceived as data loss. Like you would query your data, but you wouldn't get a proper result. Or sometimes there was like a mismatch in the way that how you queried it. Like you could retrieve that object if you used a filter that matched its ID, but you couldn't retrieve the object by its ID. And this is the worst for a database. This is really, it really shows like, yeah, you've managed to somehow corrupt your index. And by saying you, that doesn't mean that the blame was on the user. Not at all. Like they couldn't do anything about it. It was just a bug in Weaviate. And as with all of these bugs, this bug was it was essentially like a 1 or 2 line fix. It was just really like one edge case that was somehow missed. And I want to plan like a Twitter thread about what is exactly going on with that bug. I think that's a bit too detailed for the podcast. But yeah, it just makes me super happy that we have users finding these things, then we get the help from the community to reproduce it, and then it's sort of this nice interaction back and forth of our engineers and our users to really identify these these bugs and then really fix them, and of course also add the testing infrastructure to make sure that we never regress on those kind of bugs. Like if a bug is discovered and fixed once, like we never want this bug to reappear, and we're adding the tests, and we're adding like new and creative ways of, internally we call them like stress pipelines or chaos pipelines, where really we're just trying to simulate users that make heavy use of Weaviate. Like, for example, they're importing a lot, they're querying while importing, and then the server crashes every minute or something. And then like the goal of the pipeline is, first of all, it needs to come back up. But also when it comes back up, it needs to, like, the data can't be corrupt. Like everything, every write that was acknowledged to the user needs to be or actually written to the database, and these kind of things. So these pipeline help us tremendously to really guarantee sort of, yeah, this battle testedness of Weaviate by sort of automating what we're getting from the community. And every release is better than the last. And really think that 1.14, as like, if I had to point at one point in our timeline, would say like, okay, for whatever reason, I was waiting with going to production with Weaviate. When should I go? Then like this is the point right now. This is we're getting all that feedback from semis, sort of customers, so paying customers and users, from the community, from our own setups that we're testing internally, and we fixed. So I don't know the exact number right now, because we're recording this slightly before the actual release is out, so the number may still go up, but we're somewhere in the range of like 25 plus issues that are fixed in this particular release. And some of those are super critical, like the one that I just talked about for the data loss. Some of them are just some small edge cases where maybe if you set a different a specific parameter in some sort of filter, you would get an error message, and then okay, you could fix it by just setting something else. So it's like a mix of very large and very small issues. But yeah, just all of them coming together and all of them being fixed right now, that makes me so proud of our team, and so proud to yeah, sort of announce Weaviate 1.14.
Yes, so it's so interesting, the flywheel of community and open source software, and like pull requests, issue raising, and the way that it's all organized. That whole thing, I think, is such an interesting topic. So yeah, so I guess is there, so yeah, 25 issues mentioned, and I think it was a great detailing of particular bugs, and I imagine the monitoring and observability, that probably helps a lot, right? With especially with importing and querying while importing, as you mentioned. Yeah, hopefully content like the podcast also, and just kind of content generally, helps educate people and just make the flywheel spin faster with the whole the whole scope of the thing. So so I think that's a good coverage of reliability and fixes. And I think this next topic in the update is kind of related, is it, with the API changes and
Yeah.
namespace update is.
Yeah. In a sense, you could say that this was also a bug, but it was more of a design bug. So this ties very well into what you mentioned before with the different classes. So you gave the example of like a tweet, and maybe that has a link to, I don't know, post or something. So you would have two separate classes, and the concept of having different, yeah, classes or different collection or different namespaces in database, I think that's as old as databases. So if you spin up a MySQL database, there, I think they're called databases. If you spin up Elasticsearch, they're called index. So this kind of concept of isolation is very, yeah, it's very useful. Like if you want to do multi-tenancy, or if you just want to separate, like even if it's the same tenant, but if you just want to separate data somehow, it makes sense to isolate stuff. And there was one problem in Weaviate, which is technically everything is isolated on disk already. So these never, as you said before, also we would build a different HNSW index for each class. And not just the HNSW index, also the store around it. Everything was isolated on disk. But then there was one point in the API where actually that isolation was missing. And most notably, so this was basically for the V1 objects and then ID endpoint. If you would create it, wasn't really a problem, because in your payload, when creating an object, you would specify a class name. So basically you would have that isolation, which is the class name. But now if you deleted something, you would just delete object's ID without specifying the class name. So if your ID actually existed in multiple classes, which should be fine, because we're saying these are separate collections. So we're saying like, yeah, that's fine. Like you can no need to keep IDs globally unique because these are separate. Then what should happen? Because this is and this is what I'm saying, like it's a design bug, because I think there is no good answer. And way back we had a bug where I think Weaviate would delete the first object that it would find with that ID, which is this. I mean, this is horrible because like, what does that mean? Like you meant to delete one from one collection, but it would just delete the first one that I found. And then at some point we fixed this, and fixed is really in quotes here because it was more like a workaround of saying like, okay, the delete function will actually delete every object that has that ID. So it kind of gives you the guarantee that the object with this ID is deleted, but it was still a mess because like if that ID really existed like in 3 different classes and you wanted to delete just one, all of a sudden you would delete like 3 objects, which means 2 of them you might not even have wanted to delete. So long story short, this is actually a very simple change. All we're doing is changing that API, and by changing, there's no breaking change, so all the old APIs are still going to work. You'll probably see a couple of deprecation messages in the clients, but everything is still working. But we're simply changing this API to include the class name, and that's basically it. It took me 10 minutes to explain, but now you have that isolation, and now basically all of these problems are gone, because anytime you reference an ID, you also reference the class name with it, and now we have that completely separate namespacing, basically.
Okay. So could you tell me a little bit more? So when you're saying isolation, I'm thinking you mean isolation of the different classes, so tweets, articles, but then there's also the vector index and the object index, right?
Mm-hmm.
Is there, so what goes into the object index? I know we talk a lot about the vector index, but is there any particular structure, like maybe like I've heard of like inverted file? Is that the correct thing to say?
Yeah. Yeah. So I think we can split it up even further and could basically say there's 3 parts. There's the vector index, which we've talked about quite a bit. Then there's the object store, which is basically just a key value store. So every object has an ID, and you can retrieve that object by its ID. You can delete it. You can update it, replace it, these kind of things. And then we have the inverted index, and the inverted index is it's very similar to the object store in the sense that it's also an LSM store, to throw in just yet another buzzword here. So that's the architecture behind it. Goes too far to explain what that is for now, I think. So they're very similar in the sense that they're both LSM stores, but the purpose is quite different. So the inverted index basically is there for filtering. So for anything that's structured search, basically. So if you would have a property color, and then it would be blue, red, green, and you would set your filter in your search color blue, then probably should have used color pink as an example, or color whatever the name of our Weaviate green and blue is. So well, green and blue is in there.
Yeah.
just red was the wrong one, should have been pink. So if you set that filter to something like color blue, then the inverted index would be used to narrow the search down, basically. So in the inverted index, that's why it's called inverted. You would have an entry not per object, but per value. So that's the inversion, basically. So there would be an entry for blue, and then it would point back to all the objects that are blue, basically, or that have color blue set. And and these are technically separate instances on disk, but Weaviate combines them in a very intuitive way. So you can set a filter and you can set a vector search, and then basically the inverted index would create what we call this allow list, which is just sort of a list of objects that may be contained in that search, and it would pass it on to the vector search, and then the vector search is optimized to sort of work within that allow list. And this way you have like combined filtering of or combined vector search and filtering.
Yeah, really interesting. That kind of symbolic filtering on the vector search, I think, is a huge part of it, and definitely an interesting part. So I kind of wanted to ask, so the LSM thing, I don't want to get too into it, but I kind of understand it as being like a binary, like a B tree kind of, right? Some structure like that where you, is that correct? Like where you...
It serves the same purpose as a B tree or as a B plus tree, but it's actually a slightly different structure, because B plus trees basically have that, and now we're in a big data area again. So B plus trees have that problem that the more you import, the slower it is to import something, because basically the tree grows and grows and grows. LSM trees sort of turn that, or I think they probably shouldn't be called trees, but I think that's the official name. But LSM stores basically do it in a sense that whenever you import something, you always import into a fresh segment. It's called a segment. And then once a segment basically is flushed to disk, so the segment is first held in memory, but no data can be lost because parallel to writing into the in-memory segment, you also write into a write-ahead log. But once this memory segment is basically flushed to disk, then an async process sort of merges that segment with existing segments. So the write speed is pretty much constant. Like, doesn't matter how many objects you already have, it's constant. And this is super important for these like 100 million plus scales, because way back, I think in before version 1.4 or something, we actually used a third-party library that was based on a B plus tree. And back then, I think we were talking like very different. This is so cool to see where we've come. Like we're talking about the hundreds of millions and the billions. And back then, I think we were, I don't know. Yeah, I remember like a million was a barrier, and like the B plus tree would really, especially if we also use the inverted index, like a million plus was really the point where the B plus tree sort of slowed down. And that's when we made the change to the LSM tree. And yeah, now we're talking about the hundreds of millions and billions.
So does it have a lot of overhead? Would some users want to turn that part of it off and have no inverted file, just the vector index and that kind of thing?
That's a viable option. Like if you I don't think it has massive overhead, but maybe if you so essentially the overhead is the number of properties that you have, because for each property, like one bucket, and a bucket is the unit within the inverted index. One bucket is basically created for each property. So let's say you would have, I don't know, 100 properties on your object, but you're ever only querying two of them, or only ever using two of them in filters, then there's absolutely no need to index those remaining 98 ones. So you could absolutely turn them off. Yeah, that's a good point. You can, in that sense, you could turn off the entire inverted index if you just ignored, if you skip basically every property. You would lose the ability to filter. But yeah, that's a viable case. If you know you don't use filters during your search, like don't need to spend the time on indexing it, don't need to spend the disk space on indexing it. Yeah, so it's absolutely viable. The object store itself you cannot turn off, because like whenever you get a vector search, like you don't just get an ID back, right? You get the whole object back. So that needs to be there, because that's in my opinion that's one of the distinguishing factors between an actual database and like a search library. You could, like a search library would tell you the results are ID 17, ID 19, and ID 22, and then you would have to use like a separate database to retrieve whatever that ID represents. But because Weaviate being a sort of a vector database, you could just get the whole object back.
Amazing. Thank you so much, Eddie. And I love our podcast talks. It always really increases my understanding of Weaviate and the whole database thing, really. And I really enjoy this. And version 1.14, to quickly recap: changes in monitoring and observability, reliability and bug fixes, support for non-cosine distance, L2 dot product, and also some API namespace changes. So listeners, I really hope you enjoy this kind of like podcast style of doing a new release, and it's something that we're going to hope to keep doing. And I think it adds a nice kind of conversational flair to it. And I hope that also kind of this like teacher student with Etienne teaching me these things, and hopefully I ask questions that you also are at that level if you're not quite on the expert level, and it clarifies these ideas. So thanks again, Etienne.
Thank you very much. I definitely enjoyed it. Hope our listeners too.